Hi, it's Coombs from Define Tomorrow ComputerWorld. I'm here on the NVIDIA stand at VMworld in Barcelona 2017, joined by Jason Southern of NVIDIA.
Good afternoon, Barry.
Afternoon. So Jason, NVIDIA, good supporter of VMworld, been here for many years. Yeah. Lots of good announcements going on over the last sort of month and a bit for you guys. Maybe you can tell us a little bit more as to what's going on in the world of NVIDIA.
Sure. So as you and I think every one of the viewers is aware, NVIDIA's been around the virtualization market for about 4 years now, and we've had the virtual GPU technology. So, as you say, strong supporter of VMware and the events here. So what we're doing here is showing off the latest generation, and also some features that are kind of early access, early previews of technology that's going to come down the line as well. So what we'll do is we'll take a chance to go around the booth and have a look at some of the current generation of the Pascal cards, so which were announced and made available for the beginning of September.
Okay.
So we'll take a look at those demos there. Some comparisons of Windows 10 with GPU versus Windows 10 without a GPU and CPU only, and so we can show the difference in experience and the benefit that the GPU brings. And then also go and look at some new technologies that will be available soon.
Okay.
One of the biggest ones that I think most people are going to be interested in is vMotion.
Yep.
The suspend and resume of GPU-enabled VMs, but also VROPs, the ability to monitor the performance of a virtual machine with a GPU attached in that virtual environment. So if we take a look at some of those demos now, we'll take it from there.
That'd be really good. Just to cut in just a few of those things.
Yeah.
So obviously the new Pascal cards, what is to a layman's terms, what is the difference? It's the latest and greatest version of the Pascal GPU,
yep. But
what does that actually mean to the end user and to the people that are using or creating these virtual environments?
Sure. So if we explain what I mean by a Pascal card and Pascal generation. So we name each of our generations and each of our GPU architectures. So when Grid was first released, it was Kepler. Okay. And that's where K1, K2 comes from. And then the second generation for the Grid hardware was Maxwell, hence the M60, the M6, the M10. And now is our Pascal generation. So it's the name of the architecture and the underlying architecture. The changes in the card is that what we've done with this release, and this release of the Grid software, is we've enabled every Pascal card that we produce to run Grid. Okay. Or Grid software will run on every Tesla card that runs Pascal. So there's now a much broader scope of cards to choose from. Everything from our high-end P100 right the way down to the small P4 card. So it gives the customer and people like yourselves who are architecting solutions to much more flexibility in what are the options available. And we can have a talk about the different cards and how they offer there, but probably the sweet spot in the middle for most virtualization projects will see the P40. And our P40 moves from a dual GPU card, which we had with the M60, to a single GPU card, but we've put 24 gig of RAM on it. Okay. So it's a really big, powerful card. You can get a lot more users on, relatively speaking. So
it's all around flexibility, isn't it? And at the end of the day, if we go back 4 years ago, I suppose before you guys were involved in the industry, VDI was very pigeonholed to certain use cases. And if you were trying to do anything that was remotely intensive, it wasn't really a good option for VDI. And some people have still got that kind of thought process in their mind at the moment. They've looked at it, they've discounted it, they've not carried on down that path. Obviously, what NVIDIA are able to do now, almost any type of work is able to be ran on a VDI desktop now, isn't it?
That's right. And this is one of the things that we'll demo and show you a demonstration of shortly, is comparing and showing a demonstration for just the normal user. I say the normal user, somebody who's running Office, Windows 10, the browser. How does it enhance their experience? And maybe not just how it enhances the experience for them, but what's the benefits for the IT department and the people that are architecting solutions? But one other thing that we also introduced in the latest release is the ability to take this beyond the desktop environment and provide compute within a virtual environment. So over the last few years, we've had a lot of questions and a lot of people interested in how do I introduce parallel processing of compute into a virtual environment. And in the past, it's been a pass-through one-to-one relationship with a GPU. So the latest release in conjunction with the new Pascal cards, that allows us to take a virtual machine with a virtual GPU and have CUDA processing. So CUDA being the parallel processing language that we allow customers to and partners to develop their code in. So that is now available in all those virtual GPU environments as well. So again, additional flexibility stepping beyond the VDI environment.
Definitely, we're seeing NVIDIA getting involved in a lot more these days. I mean, if we go back in the days when I was younger, NVIDIA used to be about gaming, and that was what I thought of initially. And then obviously I got more familiar as to what you were doing around GPU technology, and then lucky enough to go over to your headquarters a year or so ago, and you guys are centric to what's happening with AI, autonomous driving, all these kind of things. So it's exciting times for NVIDIA.
It is very much so. And again, coming back to that compute in a virtual environment, inferencing, which is the end activity of machine learning and AI, that can now take place in a virtual machine. Huge flexibility to customers and partners that want to go out and deploy that. But yes, NVIDIA is really at the center of the next generation or the next industrial revolution, that true automation and artificial intelligence upswing. So yeah, it's very interesting times for us all.
Yeah. Fantastic. Let's go and see some demos of the technology in action.
Let's go and do that, Barry.
So I'm now joined with Luke. We're going to have a look at some of the technology in action. So what have we got here? What's the demo?
So we put a couple of demos together here, and really it's a tale of two stories. So what we have on top are SolidWorks Visualize, right? So this is a real-time rendering application that's making this object photorealistic by tracing all the light rays that might be touching this. And what's interesting is the background is actually our yet-to-be-finished corporate headquarter building, also rendered in photorealistic. So there's a tremendous amount of activity going on here. But what's truly exciting about this particular, and as I move the model, you'll notice that all the photons are being retraced, right? So there's a tremendous amount of CUDA compute going on, as well as the graphics visualization piece.
This isn't simply a 3D picture that we're rotating.
This is real time. So as I move the object, it pixelates, and then as it slowly traces every one of the photons that are bouncing off of all the objects, including if you look at the reflections in the rear glass of the car, it's reflecting as an environment around it that's not even real.
So this is taking a demo I've seen before. You've got, I think at your headquarters I saw a demo of a drill, and there was, one of them was the actual drill on a background and one was a screen. And it was, which one's real? And
that was just a drill. Exactly. This is an entire car inside of an entire building, none of which is now real, but looks incredibly photorealistic.
Indeed.
But what's truly exciting about this demo is the fact that the car on the other side is also on the same GPU being shared in a virtualized environment. Something that previously we would call that a noisy neighbor, right? If I'd ran this sort of workflow, I would never expect a good user experience on the other side because of the sheer demand of resources. But leveraging our software on top of our hardware, we're now able to actually manage and distribute those resources in a way that allows both users to have a meaningful experience. So there's sort of a high-end Quadro virtual data center workstation story. While underneath it, yet another demo, and what you have here is two identical Windows 10 desktops, right? In both cases, they're playing videos, right? We play videos every day now.
It's part of our everyday lives.
It really is. Whether we're watching news or something like that, or maybe it's a training video or Safety HR or something like that. I also have a WebGL app open because, frankly, we're in a day and age where so much of what we do is online, HTML5, that sort of thing. But we're not trying to show here some high-end 3D workflow. This is really about Windows 10 knowledge workers, digital workers, and the work they're doing. And so if I get this ball to bounce up and down, you'll notice the water's really smooth, the video's playing in the background, and CPU utilization over here is averaging about 16%. If I right-click on the desktop, you'll notice NVIDIA driver. So this is a vGPU delivered desktop. If I come over to this other one, everything's identical. If I right-click, no graphics driver, right? So there's no GPU acceleration. And now if I drop the ball in the water, look at how much slower. You just don't get the level of performance, and yet if I look over here at CPU, now notice that my CPU utilization is 94%. I'm also seeing about twice as much system memory use. If I'm talking about scalability and performance, by taking that GPU away, I've just completely hammered the amount of scalability and the amount of performance that I can deliver to my end users.
People just don't appreciate. They think of GPU as, hold on a minute, I'm not doing CAD, I'm not a gamer or anything like that, why do I need GPU?
Right, so the point of the demo then is, this is obvious, right? I've got to have a GPU here. But here, why do I need a GPU? You absolutely need a GPU.
I think it's also use cases, things like PowerPoint is incredibly graphics intensive. People have got mobile phones, they use them every day, they have powerful GPUs in them, yet people consider when they start moving to a VDI VDI desktop, for some reason they can get away without
Exactly.
it, and it puts a lot of pressure on that environment.
And it's little trivial things too that add up. I mean, I think we look at digital workers and we say, oh, you know, a knowledge worker, digital worker is not as intensive as the engineer that maybe is moving this. They're not going to move this drawing around all the time, this object, right? That's not. An engineer is methodical. They're thoughtful. They're developing or creating something.
Yeah.
If I go to a knowledge worker, though, the speed in which they move between tabs, or that they scroll, or they cut and paste and generate content, right? Whether it's at PowerPoint or what have you, that's at a far greater rate. And if you add all those little needs up, it actually, and oftentimes, becomes more demanding than some of these higher-end users.
Or just comes down to user experience at the end of the day. If the user is frustrated, unable to do their work, they're going to end up being unproductive. If we can make them more productive, if we can improve that user experience, it's going to ultimately mean better value for money out of that worker for the company.
And if you build something, I don't care how spectacular it is, but if you build something and you don't build it in a way that your users want to use it, if you build it and nobody comes, have you built anything?
Exactly.
Right?
So thank you very much for the demos. We'll now move on to the next
Let's
section.
move on some more.
Thank you. Well, obviously on the other side, we're really looking at the user-centric vision, really the user experience and what the user was experiencing and could benefit from the GPU. On this side, we're really focusing more on the IT administrator, the person that's managing this environment. Whilst NVIDIA are doing fantastic work to kind of go from the physical GPUs, introduce virtual GPUs, you try and align that then with the virtual infrastructures. There has been some limitations over the past few years, which are now really starting to get blown apart, and we're getting to a kind of equal footing that we expect to see in a virtual infrastructure. So the first element is being able to kind of monitor what's going on with the GPUs in your virtual environment to make sure you're able to size it correctly, make sure you're able to get to the root cause of problems really quickly. So we've got a demo of, is it vRealize integration first?
Yeah, and I think what's really critical about understanding why we get so excited about maybe these management pieces, which, you know, in an NVIDIA world, right, we're all about the user experience, the graphics, the visualization piece, but you know, frankly, Grid and in general, what we're trying to do here is something that is an enterprise answer. And the reason we blew apart, as you said, the software and the hardware piece is we needed to be able to develop software faster than maybe we were necessarily developing hardware, or vice versa, right? We needed to be more nimble. And that allows us, it frees us up to do things like create the ability to do monitoring and management within vRealize, for example. You can't manage what you can't, what you're not monitoring, right? So if I don't turn on monitors that give me visibility, and up till now, we've really only had visibility into the host, which is great and important. But we all know that it's the guests running on the host and the individual guests and then the individual processes within those guests where you really need to see what knobs do I need to turn in order to deliver that best possible user experience that we saw in the other demos.
And this is really important. I mean, as part of the NVIDIA community, this is something that people were asking and asking for. They love the technology, but they wanted the tools.
Yeah, and it really gets down to that demand that you all had about a single pane of glass. The ability, how can I understand what my users are currently using? How can I future-proof and plan for any growth or expansion? You know, where are my users headed? Or where have I over-allocated? Can I get benefit back? You know, can I take back some resources and better distribute that for a more efficient and more cost-effective deployment? And you just can't do that without great monitoring. And so we've been working with many different platforms, but what we're excited about on this particular launch is the vRealize piece, right? So the same tool set that any VMware sysadmin is going to start with, right? That vRealize platform, they now have an ability to have that granularity of view. Why is this important? Well, because I think the one thing that everybody's been asking for since day one is when do we get motion, right? When does vMotion become possible? And if you stop and think about just how hard it is to take something, now it's hard enough to capture a working guest and move it, right? But if I start looking into the, at 60 frames per second or 30 frames per second, 16 milliseconds to 32 milliseconds of time that I'm allowed between frames to move something without interrupting an end user's experience, that's a heck of a hurdle, right? Trying to get over that is a nightmare. And so we've been saying for a long time we're working hard on it. Well, I have a tech preview now. So, tech demo. It's funny. We have to be very careful in the language here because we don't have a time frame yet. Okay. But we did want to show that we are making significant progress, and here it is. And so we actually have a live demo.
We all remember the first time we saw a vMotion, and this is going to be the first time that I've seen it with GPU. Right,
exactly. So what we have here is a couple of host servers, right? We have a guest that's on one of those. It's currently sitting on .1 for an IP address. And really there's, I think you would expect some sort of like fireworks, right? But I've always said that one of the worst demos I can possibly do is motion, because if it's successful, you see nothing, right? Nothing happens. But in terms of migration, it's all, very standard. I'm selecting a compute move. I'm going from 3.1 to 2.1. And we'll just click next through all these. And you get to see the job has begun. Now, on this side is the actual guest that we're going to be moving. And you'll notice that we're running Unigine Heaven in the background. That Unigine Heaven will freeze briefly. Okay. The desktop's basically the state is being captured, and we're going to move that to the other host. Okay. Once the move is done, as you would expect, and it's completed, we're back to no interruption to the end user. Now, I think also important to note is we're also talking, and we don't have that demo running at this particular station, but suspend and resume. And the reason that I think it's important that we don't dismiss suspend and resume, because vMotion is the sort of the eye candy everybody's been waiting for, right? The real treat. Suspend and resume, if we talk about the ability to have compute, CUDA, OpenCL workloads, and this idea of universal use of GPU across all these workflows, then I have an ability, maybe after hours, workers go home. If I have a desktop and I can go look at processes thanks to the monitoring and the management piece, and I go, there's everything's idle. Well, then I'll vMotion that. But if on the other hand, what I have is a designer or an engineer, somebody who's doing a render job, and I can see that process is going, I don't want to kill their work, but maybe I want to do maintenance on that host server. So the ability to suspend that, move it as a suspended object, frozen in time, do my work, move it back and resume, gives me a whole nother option on top of vMotion to be able to satisfy the needs of all these newly enabled workflows.
So it's all about flexibility. We spoke about flexibility for the users, but this is flexibility for the admin, because at the end of the day, the users will become dependent on this technology. They will want the ability to be able to connect from anywhere at any time. The problem is for the IT admins, with the way the technology sits at the moment, it's very disruptive for both IT admins and the user to have to shut that virtual machine down to move it to go somewhere else. So you're able to kind of, as I say, a first gap, the dream is vMotion, complete no downtime, but this is a fantastic first step. Excited to hear in the future as and when it may be available.
Yes.
Fantastic. So thank you very much for joining me today.
Thanks for the time.
Really enjoyed having a chat. Thank you.
Perfect. Thank you.